Hi, this is Engineer Rafi, and welcome to our online review for civil engineering board exam. Okay, today we will discuss about the elements of parabola for us to understand better the general equations and the standard equations of a parabola as we discussed previously. Okay, what is this 4a? What is this hk? Okay, as you can see in these equations. Okay, we also discuss about the definitions of the parabola, a locus of points such that their distances to a fixed point called focus and a fixed line called directrix are equal. Okay, so for example, this is our parabola. Okay, this is our x-axis and our y-axis. Okay, this is at 0, 0. Okay, if this is our parabola, this is the vertex at h and k. Okay, this is the x and y of the vertex. Okay, this is the x-intercept. Okay, this is the x-intercept. Means to say that at this point, the parabola touches the x-axis. Okay, both on this point, and this we have the y-axis, means to say that this parabola touches our y-axis. So therefore, this is our y-intercept. Okay, another elements of a parabola is the axis of symmetry. Okay, the axis of symmetry is the one parallel. If it is opens upward, it is the one parallel with the y-axis. Okay, so this is the axis of symmetry. If it is opens to the right, okay, if it is the parabola opens to the right, the axis of symmetry is parallel with the x-axis. Okay. Okay, this axis of symmetry divides the parabola into two symmetrical parts. Okay, meaning to say this area or this region is the same as this on the other side. Okay, symmetrical. Axis of symmetry. Along the axis of symmetry, we will find the focus. Okay, the focus. This focus is a fixed line along the axis of this focus is a fixed point, okay, such that from the definition of a parabola, that all points, okay, along the parabola, their distance to the focus, okay, like for example this, if this is our point along the parabola, their distance to the focus, let's denote it as df, is the same as the distance to its directrix. Okay, so assuming that this is our directrix, so a directrix is a fixed line as a property of a parabola. Okay, directrix. So it means to say that this distance is the same as this distance. Let's denote it as df. And this is a perpendicular line, okay? Because the shortest distance from a point to a line is the one perpendicular to it. Okay, so that's make him a parabola. Okay, that's the most important property of parabola, that these distances are the same. Okay, although in our figure they are not, seems not to be the same. Okay, but if we will graph a correct parabola, then we will find out that this distance is the same as this distance. So that's why the eccentricity of a parabola is equal to 1. Eccentricity means that the ratio of the distance of a point to the focus and the distance to the directrix is equal to 1. So for example, this is 4, so 4 divided by 4, that is equal to 1. Okay, so that is a focus. How can we locate the location of the focus from the vertex and the location of the directrix from the vertex? Okay, check our next video. Okay, I put the link at the end of this video. Okay, for now we will only discuss focusing on the elements of the parabola. Okay, next point. So next one is the distance from the vertex to the focus. If we let it as A, if we will denote this as A, means to say that the distance of the vertex to the directrix perpendicularly, this is also A. Okay, and if we will draw a horizontal line, okay, along the focus, horizontal with the x-axis, okay, this is what we call the latus rectum of the parabola. Okay, it's what we call the latus rectum. Latus rectum. So if this is A, meaning to say this is automatically to be 2A, and this is to be automatically to be 2A because these are symmetrical from the axis of symmetry. Okay, so this means to say that if this is 2A, this is also 2A, right? So from this point to the directrix, this is 2A. Because any point from the parabola, the distance to the focus and the distance to the directrix are equal. So if this distance is 2A, so this distance is 2A also. So therefore, the measure of our latus rectum, that is equal to 4A. Okay, so that's equal to 4A. The latus rectum is from this point to that point. Okay, next. So from the standard equation of a parabola, okay, I'll show you. If the vertex is at 0, 0 and the vertex is at HK, so this is now the 4A. This is a latus rectum. Okay, 4A. This is the latus rectum also. Okay, so this would be all, and then we will now check some sample problems. Okay, we will determine the coordinates of these points and including the measures of this given the equations of the parabola. Okay, we will start about finding the vertex of a parabola. Okay, please check our next video. Thank you.